Hello, welcome back. We're going to continue with the ifs and elses, but now we're going to compare strings of text rather than numbers. The principles work the same, but we have some special commands reserved for that. So let's go to an if-else that involves a string. So we can compare two strings to see if they are equal, right? But we don't use the double equal sign like we would with numbers. We use this command, which I call dot equals. In front of the dot equals goes the name of a string, and in the parentheses is the other string. It could be a name of a string already established or literally a string inside of quotes. So in this case, we set the string s equal to 1. And if s equals the string 1, we print this. If this ends up being false, we will print that. So, well, as you might guess, since the string s is equal to the string one, 1 is 1. If we change it, if we make the string s two, for example, the string s and the string one are no longer equal, so we will use the else case. It is false that these two strings are equal. The string s is two, the other string one are not the same. They're not equal, so we use the else case. So the equals function, or equals method, is a Boolean. It returns either true or false. True if they are exactly the same, false if they are not. So I'll usually call it dot equals in class. A, because the dot appears in front, separating the first string from the command. And also because then you'll know I'm not talking about the equal sign. I'll say dot equals, we're talking about comparing strings. Now, when comparing strings, Java is, of course, case sensitive. So if you're just looking to compare if they have the same letters regardless of case, we have this method called toUpperCase, which will take any string you put in of letters and convert it to, you guessed it, uppercase. So I have this string comp sci. I'll print it out. I will then change it to the uppercase version of that string and print it out. And to show you that the lowercase version of that command works also, convert it to all lowercase and print it out. So again, the original string s, after converting it to uppercase, and then after converting it to lowercase. One thing to be aware of, suppose there were some capital letters in the original string. Suppose I capitalized comp and sci. You don't get that back when you go back to lowercase. So the original string, capital C, capital S, to uppercase converts it all to uppercase letters. To lowercase converts it all to lowercase letters. So you lose the original capital letters. So just something to be aware of, that you can't go back to the original once you've changed it via the case functions. But it is convenient if you want to check to see if two strings are equal regardless of capitalization. Convert them to both uppercase or to both to lowercase, and you can then compare them in a case insensitive way. Now, so we'll talk about string references The double equal sign compares something slightly different than what we want when we're comparing two strings. The equals command tells us whether they are exactly equal. We also have another command which is equivalent to less than and greater than or equal. It's called compare to. It compares two strings and tells you which one of the two would come first in the dictionary alphabetically. Not the one I wanted. So I'll do compares to in a moment. But we've got equals, which we talked about. Compare to, which compares essentially less than, greater than, and equal to. Right? Two that are optional. They're mentioned in the PowerPoint slide if you want to take a look at them. Trim and replace all. They could be useful, but they are not part of the testable AP comp sci subset. I won't be mentioning them or requiring you to use them. And the two uppercase and to lowercase could be useful when comparing things, so I wanted you to know about those. So, don't worry about this one. It's another use of the equals command, but the compare to is the one I wanted to show you. Compare to. So we have a string that is region and a string that is state. And we can compare those alphabetically. Now, one way of thinking about it is that region is less than state in that it precedes it alphabetically. So in the dictionary, region comes before state. So again, it's not strictly speaking less than, but it does precede it. So it does, when comparing it, it does less than and greater than in terms of where it appears in the dictionary. So this first one, we'll take the string region and compare it to state. So this one is less than the string 2. And the thing about compare to, you have a string in the front by name. You have a string in the parentheses, which can be by name or the string itself in quotes. It returns a negative value if string 1 precedes string 2 alphabetically. So if string 1 here in the beginning is less than string 2, it will return a negative value. It returns 0 if they're equal, and returns a positive value if string 1 is greater than string 2. That is to say, if it follows string 2 alphabetically. So, just as an example of that, let's go in, let's run the program. So what do we get? In this case, region compared to state. Region is less than state because it precedes it, so you get a negative value. The second time, it's the other way around. State compared to region. Okay. State follows region in the dictionary, so we get a positive value. Now if we change string 2 so that it's the same as string 1, now we're comparing two strings that are exactly equal, region and region. If they're exactly equal, you get a 0. So again, if the first one is less than the second one, precedes it, negative value. If the first one is greater than the second one, positive, gives a positive value. And it won't always be -1 and +1. the values are -1 and +1 because those first characters are off by 1. If they differed by more than that, you would get a different value. So for example, if I made it a U, now they're off by 3 letters. I compare them. Right. I get -3 because the R in region is 3 letters before the U in this new word I just made up, UK. I get a +3 because the first difference is 3 letters apart. So it will always be negative and positive, like I said, for precedes and follows, but the numbers may be different depending on how far apart they are alphabetically. Okay. So that's it for the day. Right? When we meet in class, we will work on the lab.